The arrival of the Novanians. The Novanian vessel emerged from the fold in spacetime with barely a ripple, its gleaming hull absorbing the sunlight rather than reflecting it. Chief Engineer Ilara stood at the observation deck, her iridescent eyes scanning the blue-green planet below. Earth was precisely as their probes had indicated, a world of chaotic beauty, teeming with life, and home to a species that had somehow managed to achieve rudimentary spaceflight despite their technological infancy. Preliminary scans confirmed the humans have achieved fusion energy, quantum computing, and basic neural interfaces, her assistant Torin reported, his voice a modulated hum that reflected the Novanians' musical language. Yet they still rely on combustion engines for most transportation and fossil fuels for energy generation. Ilara's facial ridges rippled in the Novanian expression of bemused curiosity. Fascinating contradictions. A species of extremes, it seems. The Novanians had visited thousands of worlds across 17 galaxies, cataloging civilizations and studying their technological development. They were engineers of the highest order, having mastered the fundamental forces of the universe millennia ago. Their mission was to observe, analyze, and occasionally guide developing species toward more efficient technological paths, all without direct interference. Earth had caught their attention when human radio signals had reached one of their monitoring stations. What had intrigued them was not the content, but the rapid technological progression evident in the transmission medium itself. Humans had gone from primitive radio to digital quantum-encrypted communications in less than 2 centuries, a pace that defied the standard development models the Novanians had established. "Commander Vex requests your presence on the bridge," Torin said, interrupting Ilara's contemplation. "The Council has approved first contact protocols." Ilara's inner eyelids flickered in surprise. First contact was rare for the Novanians. Usually, they observed from orbit, occasionally landing stealth teams to examine technology more closely. Direct interaction with a developing species was considered risky and inefficient. "The Council believes humans represent an anomaly that warrants closer study," Torin added, sensing her confusion. "Their technological development is unpredictable." First contact. The meeting took place in a remote desert facility that humans called Area 51, a choice that amused the Novanians when they learned of the location's significance in human culture. The human delegation consisted of scientists, engineers, and government representatives from various nations. They appeared simultaneously awed and suspicious, their emotional responses radiating outward in ways that made the empathically sensitive Novanians uncomfortable. Commander Vex, tall even for a Novanian, addressed the humans directly. "We come as observers and knowledge seekers. Your species has developed technologies and patterns we have not witnessed before. We wish to understand." Dr. Sophia Chen, head of the human delegation, stepped forward. Unlike her colleagues, her emotional field was controlled, focused. "We welcome knowledge exchange, but we need to understand your intentions more clearly. What specific technologies interest you?" Ilara admired the human's directness, a trait not common among developing species, who typically displayed excessive deference or aggression toward more advanced civilizations. "Your adaptations," Ilara found herself saying, stepping forward without protocol. "You create technological solutions that are inefficient yet remarkably resilient. Your computational systems are crude but possess unusual flexibility. We wish to understand how you conceptualize technology." Dr. Chen's eyes narrowed slightly. "And what do we gain from this exchange?" Commander Vex's ridge patterns displayed mild disapproval at the transactional nature of the question, but Ilara understood. This was how humans thought, in exchanges, deals, and mutual benefits. "Knowledge," Ilara replied. "Access to theoretical frameworks that would advance your understanding of quantum mechanics, gravitational manipulation, and neural interfaces by approximately 200 years." The room fell silent as the humans processed this offer. Ilara could sense their conflicting emotions: suspicion, excitement, fear, and overwhelming curiosity. "We accept," Dr. Chen finally said, "with conditions." The Novanian Research Facility. The agreement allowed the Novanians to establish a research facility on Earth, a compound built with a hybrid of human and Novanian architecture in the Rocky Mountains. The facility employed 300 humans alongside 50 Novanian researchers, all working on joint projects designed to help the aliens understand human technological thinking. Ilara led the research team, focusing on what the Novanians found most puzzling: human improvisation, where Novanian engineering followed precise, mathematically optimized paths. Humans seemed to thrive on imperfection and adaptation. "This makes no logical sense," Torin complained one day, studying the human repair of a quantum communication array. Engineer Marcus used duct tape as a temporary fix for a photonic crystal misalignment. Duct tape, a primitive adhesive material with no quantum properties whatsoever. Ilara had examined the repair, yet it worked long enough for him to implement a proper solution. But why not simply replace the crystal immediately? Why implement an imperfect intermediate step? Ilara had been asking herself similar questions for weeks. The humans approached problems with a messy immediacy that contradicted everything in Novanian engineering philosophy. They valued working solutions over perfect ones, speed over precision, and adaptation over optimization. She decided to ask engineer Marcus directly. "We call it MacGyvering," he explained with a grin. "Sometimes you don't have the right tools or parts, so you work with what you've got." "But it's inefficient," Ilara countered. "Our simulations show that waiting for proper components results in 27% less total work time." Marcus shrugged, a human gesture Ilara had come to recognize as indicating either uncertainty or dismissal. "Maybe on paper, but in the real world, sometimes you can't wait. Sometimes good enough now is better than perfect later." This philosophy permeated human engineering in ways that both frustrated and fascinated the Novanians. Humans seemed to expect and even plan for failure, building redundancies and workarounds into their designs rather than striving for mathematical perfection. The testing ground. 3 months into the joint research program, Commander Vex requested a formal assessment of human technological capabilities. The Council had grown impatient, wanting to know if the unusual investment in direct contact was yielding valuable insights. Ilara designed a series of engineering challenges to test human problem-solving under constraints. The tests would compare human and Novanian approaches to identical problems, measuring efficiency, resource utilization, and outcomes. The first test involved power management, restoring functionality to a simulated colony with damaged energy infrastructure. The Novanian team, led by senior engineer Kelvik, approached the problem methodically, calculating optimal repair sequences and energy distribution patterns. The human team, led by Dr. Chen and Marcus, barely glanced at the overall schematics before dividing into sub-teams and attacking different aspects of the problem simultaneously. They argued loudly, tried solutions that failed, adapted quickly, and communicated in a chaotic stream of technical jargon, jokes, and occasional profanity. Ilara watched in fascination as the two approaches unfolded. The Novanians worked in silent precision, each step logically following from the last. The humans worked in bursts of activity, intuitive leaps, and collaborative problem-solving that seemed more organic than engineered. When the simulation ended, the results stunned the Novanian observers. The human team had restored 94% functionality in 3.2 hours. The Novanian team had achieved 100% functionality, but required 4.7 hours. "This outcome contradicts our models," Torin said, his ridge patterns showing deep confusion. "They took shortcuts," Kelvik observed, not bothering to hide his disapproval. "Their solution isn't optimized for long-term stability." Ilara, however, was beginning to understand. They prioritized speed of restoration over perfection. In a real emergency, their approach would save lives, even if it required additional maintenance later. The second test focused on resource scarcity, building a water purification system with limited materials. Again, The humans' willingness to create imperfect but functional systems gave them an unexpected edge. By the fourth test, an artificial intelligence problem requiring adaptive learning algorithms, Alara had begun to anticipate the human approach. They would build systems that learned from failure rather than trying to avoid failure through perfect design. "I think I'm starting to see it," she told Commander Vex that evening. Humans design like they evolved, through adaptation, trial and error, and resilience in the face of failure. They expect things to go wrong and build that expectation into their systems. Vex's ridge patterns displayed skepticism. "That's fundamentally inefficient." "Is it?" Alara challenged, surprising herself with her defense of human methods. "Their planet has extreme environmental variations, thousands of competing species, and limited resources. Perhaps their approach is an adaptation to living in a high-chaos environment." "You sound impressed," Vex observed. Alara considered this. "I am. There's an elegance to their chaos that I didn't expect." The breakthrough. The real revelation came 6 months into the program. A team of human engineers had been given access to study a non-critical Novanian propulsion system, one the aliens considered relatively primitive, using only 4-dimensional spacetime manipulation, rather than the 11-dimensional systems their latest vessels employed. Marcus and his team had done something the Novanians considered impossible. They had improved it. "This makes no sense," Alara said, reviewing the modified design. "You've introduced deliberate inefficiencies in the quantum field generator." "Inefficiencies that make it work better in atmospheric conditions," Marcus explained. "Your design is perfect in vacuum, but struggles with particulate matter. We added adaptive field modulation that responds to environmental conditions." "But the energy cost is higher." "Yes," Dr. Chen interjected. "But it makes the system more versatile. Sometimes spending more energy for adaptability is worth it." Alara studied the modifications more carefully. The humans had approached the system not as a mathematical equation to be optimized, but as a living thing that needed to respond to its environment. They had sacrificed theoretical perfection for practical versatility. More surprising was how they had arrived at their solution. When she reviewed their work logs, she found references to bird-wing aerodynamics, deep-sea creature adaptations, and even immune system responses. They had looked to biological systems for inspiration, something no Novanian would ever consider for a physics problem. That night, Alara sat alone in her quarters, contemplating what she had learned. Humans design technology as extensions of themselves, adaptable, resilient, and deeply connected to their biological nature. Novanians design technology as expressions of universal mathematical principles, perfect, efficient, and divorced from biological constraints. Neither approach was inherently superior, she realized. They were different solutions evolved in different contexts, and in that difference lay possibilities neither civilization had fully explored. As she drifted into the meditation state that served as sleep for her species, Alara felt something she hadn't experienced in centuries of engineering work: genuine excitement about what tomorrow might bring. The storm approaches. Alara's report to the Novanian Council was met with mixed reactions. Some members found her growing admiration for human methods concerning a potential compromise of objectivity. Others saw strategic value in understanding an approach so different from their own. "We should deepen the collaboration," Alara argued. "There are aspects of their methodology that could complement our own, particularly for technologies deployed in chaotic or highly variable environments. Or we could simply appropriate their useful innovations and depart." Counselor Mavic suggested. "Direct contact carries increasing risks of cultural contamination." The debate might have continued for months, following the Novanians' deliberate decision-making process, had fate not intervened. 12 hours after Alara's report, the facility's sensors detected a massive solar flare erupting from Earth's sun, one far larger than anything in the historical record. Initial calculations indicated it would hit Earth in approximately 47 hours, carrying enough electromagnetic energy to devastate the planet's electrical infrastructure and communication systems. For the Novanians, this was concerning but not catastrophic. Their technology was hardened against such events, and their ship could easily depart before the flare hit. For humans, it represented a potential civilization-ending event. Dr. Chen didn't bother with diplomatic niceties when she burst into the Novanian command center. Your sensors detected the flare. What are we dealing with? Commander Vex displayed the data without hesitation. The human scientist paled as she absorbed the implications. This would send us back to the pre-electronic age, she said quietly. Billions would die in the aftermath. We can evacuate a limited number of your people, Vex offered, though they both knew it would be a symbolic gesture at best. The Novanian vessel could perhaps accommodate a few thousand humans. No, Chen replied, her voice finding new strength. We need to shield the planet. Ilara, who had been analyzing the data independently, looked up in surprise. Shield an entire planet. From a flare of this magnitude. That's not possible. Chen's eyes locked with hers. Maybe not with your approach or ours alone, but together, we have to try. Something in the human's determination resonated with Ilara. She turned to Commander Vex. I request permission to work with the humans on a planetary defense solution. Vex's ridge patterns displayed concern but also recognition. In all their travels, the Novanians had rarely intervened directly in planetary affairs, but they had also rarely encountered a species that might genuinely have something to teach them. Permission granted, he said finally. But understand this is not just a test of human ingenuity now, Engineer Ilara. It is also a test of your conviction that their methods have value. Ilara nodded solemnly, already mentally calculating the seemingly impossible task ahead. They needed to shield an entire planet from a stellar event with technology that didn't yet exist, using methods that might contradict everything she had spent centuries learning. As she left with Dr. Chen to assemble their team, she realized with startling clarity that she had never felt more alive in all her long existence. The impossible task. The command center had transformed into a war room. Holographic displays projected solar flare data, Earth's magnetic field patterns, and cascading simulations of global infrastructure collapse. Humans and Novanians worked side by side, the usual cultural barriers dissolved by the imminent threat. 42 hours remaining, Torin announced, his typically musical voice flat with tension. Ilara surveyed the assembled team. 30 human engineers and scientists alongside 12 of her fellow Novanians. They had been working non-stop for 5 hours, proposing and discarding ideas at a frantic pace. The humans showed visible signs of fatigue, yet their energy seemed to intensify rather than diminish with the pressure. A planetary shield is theoretically possible, Senior Engineer Kelvik stated, but would require energy equivalent to Earth's total annual production, concentrated and deployed within hours. Even with our technology, the scale is prohibitive. What about your ship's defensive systems? Asked Marcus, who hadn't slept in over 24 hours yet remained intensely focused. Could they be modified to protect the planet? Commander Vex, who had joined the effort despite his reservations, shook his head. Our shields are designed for a vessel 1/12,000th the size of your planet. Scaling is not linear. Dr. Chen, who had been unusually quiet, suddenly straightened. We're thinking about this wrong. We don't need to shield the entire planet. We need to shield our technology. Explain, Ilara prompted, sensing the human was onto something. Instead of trying to stop the flare, we let it hit us, but protect our critical systems. A distributed network of localized shields around power grids, communication hubs, and essential infrastructure. Kelvik's ridge patterns displayed immediate dismissal. That would still require thousands of shield generators deployed globally within hours, logistically impossible. Not if we use existing infrastructure, Marcus interjected, building on Chen's idea. Earth's power grid already connects everything. What if we repurpose it to carry shield energy instead of just electricity? Ilara felt something click in her mind, the beginning of a solution that was neither purely Novanian nor human, but something new. The human power grid could be modified to generate an electromagnetic counterfield, she said slowly, not to stop the flare completely, but to reduce its impact to manageable levels. Theoretically sound, Vex acknowledged, but the precision required to reconfigure global infrastructure without causing cascading failures would be impossible for either of us alone, Ilara finished. But not together. Novanian precision combined with human adaptability. We provide the shield technology and calibration expertise. Humans provide the implementation network and localize adaptations. The room fell silent as everyone processed the implications. It wasn't just cooperation they needed, but true integration of their different approaches. Novanian mathematical perfection married to human improvisational resilience. It could work, Dr. Chen said finally. It must work, Marcus added. Commander Vex looked at Ilara, his ridge patterns asking the question silently. Are you certain? Ilara wasn't certain, not by Novanian standards of certainty, but she had learned enough from humans to know that certainty wasn't always necessary for action. We begin immediately, she announced. The global effort. The plan required a level of global cooperation unprecedented in human history. Within hours, governments worldwide had been briefed on the threat and the proposed solution. The Novanian presence on Earth, previously known only to select officials and scientists, was now revealed to the world through necessity. Ilara found herself speaking to human leaders, explaining complex shielding technology in terms they could grasp, while Novanian technical teams dispersed across the globe. Each major power node will require a field generator, she explained to a room full of engineers in Beijing. Your existing nuclear plants can be modified to power them, but the calibration must be precise to within quantum tolerances. Similar briefings were happening simultaneously in 24 major cities. Commander Vex had reluctantly authorized the sharing of shield technology, a violation of Novanian protocols, but one he deemed necessary under the circumstances. The human response astonished the Novanians. Instead of panic or paralysis, Earth's nations mobilized with remarkable speed. Military aircraft transported Novanian engineers and equipment. Power companies implemented rolling blackouts to conserve energy for the shield network. Technicians worked around the clock, following Novanian specifications while improvising solutions for local conditions. They functioned differently in crisis, Torin observed, watching humans work with an intensity that bordered on frenzy. Their efficiency increases rather than decreases under pressure. They're evolved for survival, Ilara replied. Their entire history is adaptation to threats. This is when they're at their best. The shield network took shape hour by hour, a hybrid system unlike anything either civilization had built before. Novanian quantum field generators connected to human power grids, controlled by software written jointly by human and alien programmers. Where Novanian components were unavailable, humans created substitutes from existing technology. Where human infrastructure was insufficient, Novanians provided technological enhancements. 24 hours before impact, they conducted the first global test. Power surged through the modified grid, and localized shield fields flickered into existence around critical infrastructure worldwide. The energy drain was enormous, causing temporary blackouts across continents, but the system held. 62% coverage, reported Kelvik, below minimum safety threshold. We need to prioritize, Dr. Chen said. Full protection for power plants, communications hubs, and hospitals. Partial protection for transportation and water systems. Everything else is secondary. The Triege approach disturbed the Novanians, who valued comprehensive solutions, but they recognized the necessity. Resources were reallocated, shield patterns recalibrated. A second test achieved 78% coverage of critical systems. It's not enough, Marcus said, reviewing the projections. The electromagnetic pulse will still knock out significant portions of the grid. Ilara had been considering an alternative approach, one that contradicted Novanian engineering principles, but aligned with what she had learned from humans. What if we don't try to maintain the shields indefinitely? She suggested. What if we design them to fail safely, in sequence, absorbing maximum energy before collapse? The humans immediately grasped the concept. The Novanians were horrified. Deliberate system failure. Kelvik's ridge patterns display profound disagreement. That contradicts every principle of proper engineering. It's how biological systems handle overwhelming threats, Dr. Chen explained. Controlled sacrifice of non-essential functions to preserve core systems. Commander Vex, who had been monitoring the discussion, intervened. Engineer Ilara, are you formally proposing this approach? Ilara knew what he was really asking. This wasn't just about the shield design. It was about embracing a fundamentally human engineering philosophy, one that accepted and incorporated failure rather than striving for perfection. I am, she said firmly. A perfect shield that covers 80% of critical systems will result in 20% catastrophic failure. A dynamic shield system designed to fail strategically could protect nearly everything, at least from the worst effects. Vex studied her for a long moment, his ridge patterns unreadable. Finally, he nodded. Implement the design. But understand, Ilara, this decision will be reviewed by the Council. She understood the implicit warning. She was venturing far from Novanian orthodoxy. If she was wrong, the consequences would extend beyond Earth. But as she looked at the humans around her, exhausted, determined, and still innovating despite the approaching catastrophe, she knew she was making the right choice. The hour of truth. The hour of truth. 12 hours before impact, the shield network was as ready as it would ever be. The modified design incorporated both Novanian precision and human adaptability. Fields would form a layered defense, with outer shields sacrificing themselves to absorb energy, while inner shields protected the most critical systems. Ilara stood with Commander Vex on the observation deck of their vessel, which had been repositioned to monitor the approaching flare. The ship itself would be unaffected, its advanced shields easily capable of handling the solar disturbance. But both of them were thinking about the planet below. The Council has expressed concern about our level of involvement, Vex said quietly. This exceeds all previous engagement protocols. The Council isn't here, Ilara replied. They haven't seen what I've seen. And what is that exactly? Ilara considered the question carefully. A species that approaches problems fundamentally differently than we do, yet achieves remarkable results. A reminder that there's more than one path to technological advancement. You've grown attached to them, Vex observed, not accusingly but with curiosity. I've grown to respect them, she corrected. Their approach to technology is deeply integrated with their biological nature, adaptive, resilient, embracing imperfection as a strength rather than a weakness. Vex's ridge patterns showed thoughtful consideration. And you believe this approach has value. I believe diversity of approach has value, Ilara said. For millennia, we've refined a single engineering philosophy to its ultimate expression. What if that's limited us in ways we can't perceive? Before Vex could respond, Torin's voice came through the communication system. Flare acceleration detected. Impact in 10 hours, 47 minutes. They returned to the command center, where a joint human-Novanian team monitored the shield network. Dr. Chen looked up as they entered, her face showing the strain of days without proper rest. Final diagnostics complete, she reported. The system is as ready as we can make it. Marcus added, we've implemented the cascading failure protocols. Outer shields will absorb maximum energy before collapsing, channeling remaining power to inner defenses. Global cooperation status, Vex inquired. Unprecedented, Chen replied with a tired smile. Every nation has implemented the protocols. Military systems are in standby mode to reduce vulnerability. Civilian populations have been advised to disconnect electronic devices. Ilara studied the global shield diagram, a patchwork of Novanian technology integrated with human infrastructure, creating something neither civilization could have built alone. It wasn't perfect by Novanian standards. There were inefficiencies, compromises, and deliberate weaknesses built into the system. But there was also a resilience to it that pure Novanian engineering lacked. As the hours ticked down, humans around the world prepared for potential disaster while continuing to refine and adjust the shield network. The Novanians, more accustomed to cosmic threats, maintained their focus on system optimization until the very last moment. When the flare finally hit, it came with a violence that exceeded even the worst projections. The sky above Earth bloomed with auroras of unprecedented brightness as the planet's magnetic field interacted with the solar storm. Electronic systems worldwide flickered as the electromagnetic pulse washed over them. In the command center, Ilara and the others watched as the shield network responded exactly as designed, and then better than designed. The outermost shields absorbed massive energy loads before failing, their collapse triggering adaptive responses in the remaining network. Human operators made real-time adjustments, compensating for failures faster than the automated systems could respond. Remarkable, Torin murmured, watching the humans work. They're improvising shield modulations based on observed failure patterns. For 6 hours, the storm raged. Shield segments failed across the network, but always in ways that protected the most critical infrastructure. Power grids fluctuated but held. Communication systems maintained minimal functionality, and beneath it all, the hybrid technology created by two vastly different engineering philosophies performed beyond anyone's calculations. When the storm finally passed, the damage assessment began. Significant portions of Earth's electrical infrastructure had been damaged or destroyed, but the core systems remained functional. There had been no cascade failure, no global blackout. Recovery would take months, but civilization remained intact. It worked, Dr. Chen said simply, exhaustion and relief evident in her voice. It worked differently than designed, Kelvik noted, his ridge patterns showing lingering confusion. The system adapted beyond its programming parameters because humans adapted it in real time, Ilara explained. They treated the shield network as a living system, not just a technological one. Commander Vex, who had observed the entire event in silence, finally spoke. I believe, Engineer Ilara, that the Council will be very interested in your full report. Departure and legacy. In the aftermath of the solar storm, Earth faced enormous reconstruction challenges. Electrical systems needed rebuilding, communications infrastructure required extensive repairs, and the hybrid shield technology had to be either dismantled or permanently integrated. The Novanians, following intense internal debate, offered limited assistance during the initial recovery period. Their help was targeted and temporary, enough to prevent humanitarian disasters, but not enough to fundamentally alter human technological development. 3 months after the flare, as Earth began to stabilize, the Novanian Council made its final decision. The research mission would end, and all personnel would return to their vessel for immediate departure. Ilara received the order with mixed emotions. She had come to Earth expecting to study a primitive species with curious technological quirks. She was leaving with a transformed understanding of what technology could be, and what her own people might become if they opened themselves to different approaches. The farewell ceremony was small, attended only by the humans who had worked directly with the Novanian team. Dr. Chen presented Ilara with a gift, a simple mechanical watch. It's inefficient, Chen said with a smile. It loses about 2 seconds per day, but it will keep working long after more sophisticated technology fails. Ilara accepted the gift, understanding the symbolism. Resilience over perfection. Exactly, Chen replied. Thank you for seeing value in our chaos. Marcus stepped forward next, handing Commander Vex a data crystal. We've compiled our observations and innovations from the SHIELD project. There may be applications your engineers haven't considered. Vex accepted the crystal with formal courtesy, his ridge pattern showing mild surprise at the gesture. We will study it carefully. As the Novanians prepared to board their transport back to the main vessel, Ilara lingered for a final moment with the human team. Your civilization will face many challenges in the coming centuries, she told them. But after what I've witnessed, I believe you'll overcome them in ways we cannot predict. "Will we see you again?" Marcus asked. Ilara's ridge patterns shifted in the Novanian equivalent of a thoughtful smile. "That would contradict our non-interference protocols." "But," Chen prompted, recognizing the unspoken qualification. "But I suspect Earth has not seen the last of the Novanians. Some questions are worth breaking protocol to answer." As their ship departed Earth's atmosphere, Ilara stood at the observation deck, watching the blue-green planet recede. Beside her, Commander Vex studied the human data crystal. "The Council will not be pleased with some of your conclusions," he noted, suggesting that we incorporate human engineering philosophies into our own practices is unprecedented. "So was the shield network we built together," Ilara replied. "A perfect solution would have failed. An imperfect, adaptive one succeeded. You're proposing we introduce deliberate inefficiencies into our designs," Vex said, his tone neutral but his ridge patterns showing deep consideration. "That contradicts millennia of development." "I'm proposing we expand our understanding of what efficiency means," Ilara corrected. "Sometimes adaptation is more efficient than perfection, especially in chaotic environments. Humans understand this instinctively. We can learn it deliberately." Vex was silent for a long moment, his attention seemingly focused on the retreating planet. Finally, he said, "I've recommended to the Council that we establish a permanent observation post in the solar system. Discrete, non-interactive, but continuous." Ilara's ridge patterns displayed surprise. "That's unusual interest in a single species." "Earth is an unusual world," Vex replied. "And I find myself curious about what they'll do next." Epilogue. 50 years later, the Novanian Grand Engineering Academy was not easily changed. For thousands of years, it had taught the same fundamental principles: mathematical perfection, absolute efficiency, elegant minimalism. These principles had built an interstellar civilization and technologies that approached the theoretical limits of physical laws. Yet today, something new was happening within its ancient halls. Senior engineer Ilara, now elevated to the Academy Council, stood before a chamber filled with young engineers. Behind her, a holographic display showed the design principles of what had come to be called adaptive engineering, a school of thought that incorporated controlled imperfection, environmental responsiveness, and graceful failure into technological design. Traditional Novanian engineering seeks to overcome environmental variables through perfect design, she explained. Adaptive engineering instead embraces those variables, creating systems that respond to them rather than resisting them. A young engineer raised his hand, his ridge patterns showing polite skepticism. "But deliberately introducing inefficiencies contradicts foundational principles." "Does it?" Ilara challenged. "Or does it simply expand our definition of efficiency to include adaptability and resilience? A system that functions at 90% efficiency across all environmental conditions may ultimately outperform one that achieves perfect efficiency under ideal conditions, but fails under stress." She gestured to the display, which showed a series of technologies developed over the past 5 decades, spacecraft hulls that adapted to radiation storms rather than just resisting them, power systems that redistributed energy based on environmental feedback, communication networks that became stronger rather than weaker when individual nodes failed. "These innovations have all been inspired by our ongoing observation of Earth," she continued. "A species that evolved in a high-chaos environment developed engineering approaches we never considered because our evolution followed a different path." After the lecture, Ilara met with Commander Vex, now Admiral Vex, head of the Exploration Division. Age had silvered his skin, but his ridge patterns remained as expressive as ever. "The integration of Earth-inspired principles continues to meet resistance," she told him. "Many still view adaptability as inferior to precision. Yet the results speak for themselves," Vex replied. "The new generation vessels incorporating adaptive systems have shown 40% greater mission success rates in unpredictable environments." "And what of Earth itself?" Ilara asked. "Has there been any reconsideration of the non-contact directive?" Vex's ridge patterns showed complex emotions. They've developed faster than projected. Their understanding of quantum mechanics is approaching our level, though their applications remain uniquely human. Meaning? They've created AI systems that collaborate with human operators rather than replacing them. Biotechnology that enhances natural processes rather than supplanting them. Energy systems that work with planetary forces rather than dominating them. He paused. They're developing along a technological path we never explored. All the more reason to renew contact. Ilara suggested, not for the first time. The Council remains divided.